All right, hello Math 10 students. I'm going to be doing the lesson on bearings via this video today. So what I ask is that in order to prepare for this, that you get the packet, the worksheet, and put it right next to you and have a pen or pencil ready because there will be times during this video where I will ask you to pause so then you can give the problem a go on your own and then you can press play again to check your work to see if you were on the right track. Okay, so we are going to continue what we have learned in the last few classes with the law of sine and the law of cosines, but we're going to apply it to bearings. So what bearings are is a way to measure in degrees the position that two things are from one another. So what we use in order to look at bearings is we need to use the cardinal directions. So north, south, east, and west. And those are kind of like our benchmark directions. So we always start bearings from north, all right? So if I was to measure east, then I would start at north and I would go 90 degrees to east. So I create those lines because it helps me see what that bearing is. If I wanted to measure to south, that would be to this line, then I would need to go starting from north all the way to south, which would be a 180 degree bearing. And then similarly, if I wanted to find 275, or west, then that's gonna go from north all the way around 3/4 of the circle, and that would get me to 270 degrees. So we're always starting our bearings from north. And then from here, I can go around and measure my bearing. We are always working in a clockwise direction. So we start from north and we go clockwise. We also always measure bearings using 3 digits because a lot of the programs that look at bearings, which I'll talk about in a minute, can hold a capacity of 3 digits since 360 is the maximum that we can have for a bearing. So we just usually write that as 3 digits. It's just common. And bearings are used in many places in the world, but most commonly they are used in an airplane or in boats or some kind of sailing vehicle. So these help us to get from position A to position B. So in order for an airplane to know, it's not only its distance away from an airport, but also the bearing at which it might need to change direction in order to then go the direction of an airport. So that's probably the most common one, and that's what your pilot is looking at in order to help direct them in the direction that they need to go. Changed it up a little bit, and instead of just giving you the information, I went to ChatGPT, which I'm citing my source now, and had ChatGPT come up with this beautiful romantic poem, which I will read to you. Okay. 2 shy teens at ISK they meet, their glances quick, their hearts skip a beat. With letter sealed and hope held tight, the white dove takes its morning flight. 102 meters at 17 degrees, to PHE class with gentle ease. A friend awaits to pass love's note, her hands trembling as the bird takes rote. Then turning southeast without delay, 115 degrees marks the way. 142 meters more to go, to lower field where love may grow. Now the letter's on its quest, 2 hearts beating, love expressed. Isn't it beautiful? So this is giving us information about this triangle, but in summary, the bird is starting at the canteen, the student canteen. It is going to the PHE office to pick up a love letter and then delivering it to the other person that is on the lower field. So if we created a shape like I have already done, then we would get this nice looking triangle. And let me erase that real quick. We're going to take the information that was given to us in this poem, and we're going to apply it to the triangle. Why did that thing show back? Let's go. So 102 meters at 17 degrees. So since the dove started at the student canteen, I like to create this little cardinal direction every time that it gives me a bearing because I know that then I need to start from north. So this angle created right here is 17 degrees because it says 17 degrees and it has to start from north. My distance that the dove traveled first was 102 meters. So that's the distance of this part of the triangle. Then from the PHE class, I'm going to create a new cardinal direction because this is north-south and this is east-west. It says 115 degrees marks the way and 104 meters more to go. So bearing, again, starts at north and goes to that line that connects us to the path to the lower field. That is going to be 115 degrees. And the distance then is 142 meters. Okay, so I'm just labeling all the information that I have. And I don't know why this keeps coming up, but eventually we're going to get there. What? Okay, whatever, it needs to stay. So the first question that this asks is, what is the distance as the dove flies from the lower field to the student canteen? So from the student canteen to the lower field, that's asking for this distance here, which we're going to just label as X. Right? In order to find that, right now I only have two side lengths. I have 102 meters and I have 142 meters. So that little angle that I couldn't erase, that's the angle that I would need to find. And it would be helpful to find that because if I do have it, then I would have a side, an included angle, and another side, which means I can use the law of cosines. So hopefully you already saw that. If not, that's okay. So in order to find this angle, I need to use the bearings to help me break that angle down. So since this angle that I had from the PHE office was 115 degrees, I know that from north all the way down is going to be 180. Therefore, if I did 180 minus 115, that's going to give me 65 degrees. Okay. Now here's the other part, and this comes up a lot in these bearing questions, is because my north-south line and this north-south line are going in the same direction, that means that those two lines are parallel. I am then cutting that parallel line by this transversal, okay? And if I zoom in, then having this parallel line and this parallel line, this angle here, that's 17 degrees, is congruent to this angle here. And that's because of alternate interior angles, okay? They're alternating because they're on either side of that transversal, and they're inside of those two parallel lines. So then this is 17 degrees. Therefore, that white line, this line that I kept trying to erase, is going to be 82 degrees, okay? So now I have that angle, and I got that from using the bearings. In order to find that distance of X, I want you to think about what that equation would look like. I already told you what law to use. Let's see if you were listening. So go ahead, pause the video, write the equation, and then replay to see if you got it correct. Okay, so in order to do that, our opposite side is x squared, and then our other two sides would go inside of here. So plus 142 squared minus 2 times a times b times cosine of 82. Okay, so if I solve this, then I'm going to get x is equal to 162.9000725. Okay, but because we're rounding to two significant digits, then x is going to approximately equal to 163 meters. Okay, be careful though, because later we're going to need to use this 162.9000725 from the calculator. So don't delete your calculator because you're going to have to go back up and use that number again. Question 2 is asking, what is the bearing from the student canteen to the PHE office? So this is going to come up in a lot of these questions as well, but when it says from the student canteen, whatever comes after the word from is where you start. So I'm going to start at the student canteen, and I'm going to go, oh, sorry, I changed this on your worksheet. This should actually be the lower field. So I'm starting at the student canteen because that's what comes after from, and I'm going to go to the lower field. So let's look at that image. So starting here, so I'm using this cardinal direction in order for us to figure out that bearing. This is the line that connects the student canteen to the lower field. So I'm looking at this bearing here. So I can see that that bearing would come from 17 plus whatever this angle is inside of my triangle. So if you want to pause the video, think about what law you would use and think about how you would get that angle and then try it out. If you don't know, then stay tuned. Okay, so if you pause the video, hopefully you realize that it would be the law of sines. So I'm going to make this small so I can see all those numbers. So law of sines will help us take the sine of 82 and the side opposite of it, which is x, which this is where this whole number is going to come in. But I can just do dot, dot, dot for now. But when I plug it into my calculator, I must use this entire number. And that's going to equal to sine of, let's just call it theta. So theta is this guy in here, over 142, since that's the side opposite. Okay. When we cross multiply, I will show out all my work. So I'm going to have 142 is equal, multiplied by sine of 82 is equal to 162.900, blah, 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 sine theta. So I'm actually just going to skip a step, and it's going to be arc sine. So inverse sine of 142 times sine of 82 over 162.900, blah, 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 blah. But again, I need to put in that whole number, and that's going to equal to theta. Okay, so pause the video, see if you can put that into your calculator, and see if you can get theta. Okay, theta ends up equaling to 59.7 degrees. But remember, that's only part of what my bearing is. And sorry if that was confusing, that this is a 4. So that's only part of my bearing, right? Because we said that I need to do theta, which is, I'm using a lot of colors now, but it's this angle plus the 17. So in order to finish this and answer the question, I need to add 17 degrees, okay? So then my total will come out to 78.7. Did I do that right? Oh, 76. Sorry. 76.7 degrees. Okay. And I should also put a 0 out in front. And then that is going to be our bearing. All right. So the next part of this is practice. And hopefully number 1 is pretty straightforward. But if not, then make sure that you ask the person next to you. I am going to go over question 2A because students found this one confusing. So find the bearing of Q from P if the bearing from P from Q is blah. So I need to start with this, and then I can find this. So this is what I do second. So first, I'm going to create my cardinal direction to figure out where P and Q are. So since the letter Q comes after from, I'm starting at point Q. So that's going to be in the center of my cardinal direction. And then to get to P, I need to go 54 degrees. Again, I always start from true north, and then I'm going to go about 54 degrees. Okay, and then that's going to be where P is. All right, so now the question is asking, let me use a different color, orange. The question is asking, what is the bearing of Q from P? So now I start at P, and I need to find this bearing. So it's going to be more than 180 and less than 270. Well, here's where our alternate interior angles come again. So this is parallel to this. There we go. So, and it's cut by this transversal. So this 54 is congruent to this, which is also 54. So in order to figure that bearing out, it's going to be 180 plus 54, which is going to equal to 234 degrees. Okay, so hopefully that helps. Again, make sure that your bearings are always coming from true north. Okay, hopefully that helps. And then if you have questions, please talk to the people around you. And then always ask your teacher too if you need help. But talk to the people around you first and then contact your teacher. Okay? All right. Good luck.